Okay, so today we start a new topic, which is rational expressions. This chapter or this section should look pretty familiar to anyone who took Math 20-1, which I think is all of you guys. So this one should feel at least a little bit familiar, hopefully. And familiarity makes things a little bit more approachable and easy, so hopefully you guys find that. So if we're talking about rational expressions, the first thing that we're going to do is just identify what are rational expressions, talk about simplifying them a little bit, but we're going to do that more tomorrow. And then we'll look at non-permissible values. So to start, a rational number is any number that can be expressed as a fraction of integers, so positive or negative whole numbers, right? We don't want decimals in this fraction, as long as the denominator does not equal 0. So it's a over b where b does not equal 0. Remember that we can never divide by 0 because that gives us undefined. If you try and type in like 6 divided by 0 in your calculator, it will give you an error. Okay, so some examples of this is you could have 1 over 6, or you could have negative 17 over 100, or you could have an improper fraction, let's say negative 9 over 5. We could also have something like a decimal, like 1.2, because this is the same thing as 1 and 2/10, which is 1 and 1/5, which we could write as 6/5, right? We could write 0.3 repeating, because that's the same thing as 1/3. So any of those are considered rational numbers, and we're going to focus on all the fractional forms of these things. A rational expression, remember an expression is something that does not have an equal sign, and an equation does. So a rational expression is a fraction, or we can express that as a quotient, like something divided by something else, involving at least one polynomial. Okay, so a polynomial, we talked about these lots in grade 9. You guys would have talked about them in grade 10 and 11 as well. But the polynomial is a combination of different terms, but with variables with varying exponents. All the exponents have to be whole numbers. Okay, so either the numerator or the denominator, or both, can be a polynomial, and then we have a rational expression. So the exponent in each term of the polynomial must be a whole number. If a term contains a fractional exponent, or the exponent is a variable, the expression is not a rational expression. Okay, so this is going to be like the defining feature for some of our things. So the following ones are rational expressions. So 2 over y, 2 is a polynomial, it just has degree 0, and then y is a polynomial, it has degree 1. M divided by m plus 3, those are both polynomials. Polynomials can also be in factored form, so x minus 1 divided by x plus 2 times x plus 3, that is a polynomial. And then m squared minus 4, we could put this thing over 1, and that is still a polynomial, because we have a polynomial on the top and a polynomial on the bottom. The flip side of this, the following are not rational expressions, and we're going to talk about why. So if we have x divided by the root of x, remember from grade 11 that a square root has, or it might have been grade 10, anyways, it has an exponent of 1/2. So that exponent is not a whole number, so this thing is not a polynomial. The other thing that's happening here is we have an exponent is the variable. And we cannot have exponents in the variable. We're going to talk lots about this later this year when we get to the exponents and logs section. This is a different type of function. It cannot exist and still be called a polynomial. Okay, so this one would not be rational. The next thing that we need to talk about is a non-permissible value. So the denominator of a function can never equal 0. So just like we can't divide by 0 when we're doing a fraction, we can't divide by 0 when we've got expressions. Therefore, the denominator of a rational expression or function can never equal 0. This means that there may be values of a variable that can lead to the denominator equaling 0. These are what we call non-permissible values. Okay, so we often abbreviate that to NPV. So as an example, what are the non-permissible values for each expression below? To find those, what we do is we say, okay, m plus 3, which is the denominator, cannot equal 0, and then we want to isolate for m. So in this case, if I subtract 3 from both sides, m cannot equal -3. On this one, I have x plus 2 cannot equal 0, so then if I subtract 2 from both sides, x can't equal -2. And then same deal for x plus 3, that can't equal 0, so x cannot equal -3. Notice how we only care about the denominators here, okay? M itself could equal 0. Then we'd have 0 divided by 0 plus 3 is 3. 0 divided by 3 works. So 0 on the top of a fraction is totally okay. 0 on the bottom of the fraction, that's where we run into issues, okay? We cannot take 3 things and make them not exist. We can take 0 things and divide them by 3 people. Everybody just gets 0. When we talk about simplifying rational numbers, we want to say, okay, is there a way to simplify rational numbers? It's exactly what we do when we put a fraction into lowest terms. However, before we put our fraction into lowest terms, we're going to write the numerator and denominator as a product of its factors. So let's look at the example of a combination, okay? So 5 factorial is 5 times 4 times 3 times 2 times 1. Divided by 3 factorial is 3 times 2 times 1. And then 2 factorial is just 2 times 1. Oops, 2 times 1. So we want to cancel out any common factors. So 1 divided by 1 can cancel. 2 divided by 2 can cancel. 3 divided by this 3 over here can cancel. And then we have 5 times 4 divided by 2. 4 divided by 2, we can write those as a reduced form. So that's 5 times 2 on the top. And then we just have a 1 on the bottom. So that's going to be equal to 10. And we can check that on our calculator if we want it. So in general, if a number appears in the numerator and denominator, we can cancel it out. So if you have something like a times b over b times c, the b's are going to cancel. We need to make sure, though, that b cannot equal 0, because even though they've canceled, it was still part of the original equation. And in this case, whatever c is, c cannot equal 0. Okay? If they're numbers, 3 factorial is always just going to be 3 times 2 times 1. So if it's not a variable on the bottom, we don't have any NPVs. So if I wanted the NPVs of like y over 7, 7 is never going to equal 0. So this one wouldn't have any NPVs. Okay, to finish this one up today, we're going to do some examples. So we're going to simplify the following rational numbers. Okay, so again, we want to write these things as their factors. So 27 is the same as 9 times 3. And then 96 is the same as 3 times 32. Okay, 9 could be broken down into 3 times 3. 32 could be like 4 and 8, but nothing here is going to continue to cancel. So the 3's are going to cancel, and we have 9 over 32. It's as simple as that thing can get. Okay, this one, 36. 36 is, it is 9 by 4, but I'm going to use 3 times 12, and then 132 is 11 times 12, so that's why I wanted the 12s. So the 12s can cancel, and that's 3 over 11. If we have negative 35 over 140, that's 7 times 5, and then 140 is going to be 5 times 28, which is the same thing as 7 times 4. So the 5's are both going to cancel and the 7's are both going to cancel. So we end up with negative 1/4. Your calculators can do these for you if you ever need like help in that way, right? You can punch that in, go math fraction, hit enter, and it'll give it to you, okay? The last thing that we're going to do is go over non-permissible values, some practice. So we want to make sure that the denominator cannot equal 0. The numerator can equal 0, that's allowed, but the denominator cannot. So x plus 7 is not allowed to be equal to 0. If I subtract 7 from both sides, I get x cannot equal negative 7. If there's more than one factor on the bottom that contains a variable, we have to do it for both. So x minus 3 cannot equal 0. If I add 3 to both sides, x can't equal 3. And then x plus 2 cannot equal 0. So if I subtract 2 from both sides, I get x cannot equal negative 2. This one, I just have a more complicated factor. So remember that a factor is anything that multiplies anything else. This factor has 2 terms, and there's just one of it, right? So it's the whole thing is a factor because it could be multiplied by 1 and not changed. But 3x and negative 5 are 2 different terms. So we have to set that whole thing so that it cannot equal to 0. So I'm going to have to add 5 to both sides and then divide by 3. So x cannot equal 5/3. Otherwise, that denominator is going to equal 0. So in this one, we've got what we call a complex rational number. So we've got a fraction within a fraction. So we just know that the bottom cannot equal 0. But the bottom of the bottom, so we have this whole thing is the denominator, but just the x is the denominator. So we need to think through, okay, how could we make just this part equal to 0? So just the 1/x equal to 0. And then is there a way for that whole thing, this whole thing to be equal to 0? So if I just look at the 1/x, then I know that x cannot equal 0, because if I put a 0 on the bottom, I'm dividing by 0, okay? Since 1 is always going to just be 1, and if I do 1 divided by 1, or 1 divided by 2, or 1 divided by negative 7, or whatever, that's always going to be a number, it's always going to be allowed. There's no way for the whole thing to equal 0, because 1 divided by 0 is undefined, but either way, this is an NPV because we cannot divide x minus 2 by undefined. So it's kind of like undefined double. It makes the bottom undefined, and we can't go any further. So either way, x cannot be equal to 0. If we have something like this, our first step is to factor it. So we want to factor this thing, and it's going to take a little bit of room here, but we can do it because we want two numbers that are going to multiply. If we think through our factoring rules, they need to multiply to 60, and they need to add to 17. Okay, so the two numbers that we have are 5 and 12. Follow those rules. So we need to split, and I'm just going to work on the bottom. So it's going to be 5x squared. We're going to split that middle x term into the sum of 5x plus 12x. Then we're going to say, okay, the first two, what can I factor out? I can pull a 5x out of both. I'm left with x and 1. What can I pull out of both of these? Oh, I can pull a 12, and I'm left with an x and a 1. So that means this whole thing is equal to the x squared minus 6x minus 19 on the top, which we don't actually care about factoring. We only care about the x plus 1 and the 5x plus 12 that's on the bottom. This tells me that x cannot equal, or sorry, let's go back a step. X plus 1 cannot equal 0, so x cannot equal -1. And then this tells me that 5x plus 12 cannot equal 0. If I move the 12 over, it's -12. And then divide both sides by 5. X cannot equal -12 over 5. So we don't actually care about the numerator, we just care about factoring the denominator and saying, hey, what is going to make this thing equal to 0? Okay, this last one, we have two complex fractions, right? We have a fraction and a fraction inside a fraction. So any single denominator that ever exists here cannot be equal to 0. So if we look at just the top, 1 over x tells us x cannot be equal to 0, because if we put a 0 here, then this whole thing, the whole numerator, is going to be undefined. Undefined divided by something can't be a number. The other thing that we need to look at is that x over 2 cannot be equal to 0, right? Or it itself can't be undefined. So there's no way to make this specific section of the fraction undefined, but again, if x is equal to 0, then the whole denominator becomes 0, and we have 1 over 0. I mean, both ways it's undefined. So we cannot have the numerator on the denominator, the numerator in the denominator, being equal to 0, because it's going to make the whole bottom 0. Okay, so even if there wasn't a 1 over x up here, x could not equal 0. Okay, so we just need that 1 NPV for this one. For practice, because I forgot to print it in this booklet, so we're going to have to do this every day. So this is in your snap book. I want you to read page 178 to 182, and then do questions on page 183, numbers 1 to 6. So not too bad today, okay? If you have any questions, let me know.